Hello everybody, this is Francesc Salla from AsuniCAD, and today we will see the new features of VisualARQ 2.0 that right now is in a beta stage, but in a few weeks it will be available for everybody. So we will see just an overview of VisualARQ for those who are not very used with the program, but this webinar will focus on the new features of the 2.0 version. So VisualARQ, as you may know, is a plugin for BIM that works on top of Rhino and improves to the process of modeling architecture inside Rhino, not only for generating the 3D model, but also for generating all the 2D documentation. We say that VisualARQ adds BIM features to Rhino because all the documentation is generated from the 3D model, okay, such as the plan, elevation, sections, schedule tables, all right, and so anything that changes on the 3D model then later on updates automatically to the all the documentation that is generated from it. Also because VisualARQ works with parametric architectural objects, we will see later on a few objects that we have added in the new version, and all these objects contain information, okay, so that's why we can edit them parametrically. Also, VisualARQ provides the option to import and export models using the IFC format, the standards of all the BIM programs to exchange architectural models. So a model created with VisualARQ can be exported to IFC, and all the architectural elements will be recognized as architectural objects. Okay, and in the other way around as well. So model created with other programs that are using architectural objects will be recognized as native architectural objects in VisualARQ. Why we talk about this flexible BIM concept that VisualARQ adds to Rhino? Well, basically because since VisualARQ is inside Rhino and Rhino allows you to work with any kind of freeform shapes, VisualARQ integrates completely in the process of modeling architectural designs that are complex or have complex geometry. Okay. Also because you have total freedom to create an object, also with polysurface or freeform shape, and assign information to it. For example, we can take this polysurface and tag it as a slab, as an IFC slab. So when we export this object, will be recognized as a slab in other programs. Also because it integrates in Grasshopper. So this is some part that has been developed in the new version. And basically on one hand, there is the option to generate all the architectural objects directly in Grasshopper. So it integrates in the workflow of working with definitions and generating the objects in these definitions. And on the other hand, we will see how you can create objects, VisualARQ objects from Grasshopper definitions as well. In addition, VisualARQ has some tools to generate sections, and for visualization proposals is really useful. Okay. Also integrates with all the render engines that work in Rhino, so you can assign materials very easily in the same way as you can do it with Rhino objects. So let's take a look at the main features of the new version. Okay, so I will talk first about the new section manager and the improved level manager. Okay, they work both in similar way, and we will see the details that have been added to the level manager and the new features of this section manager. One of the killer features of VisualARQ is, as I said, the option to generate objects from Grasshopper definitions, but also to print 3D model, not only in perspective views, but also in sections or in plan views, as 2D vector drawings. Okay, this is really useful because there is no need anymore to generate 2D section views or using the make 2D command for printing the model in vector output. We'll see some examples later on. Also, we have added 3 new objects. 2 of them are 3D objects for furniture elements or for just generic elements, okay? And we will see how they work. And we have also added a new annotation object that is a generic annotation object that can be created using blocks or also Grasshopper definitions. We have added the option to add information to not only VisualARQ objects but also Rhino geometry and Rhino objects using custom parameters. Okay, since well, in the current version there is a limited number of parameters, but now it's possible to generate new parameters and assign the information not only to VisualARQ objects but also to Rhino geometry. And we will see that later on as well. Also, we have added the commands to do Boolean operations between VisualARQ objects and Rhino geometry, which is something that was only available for walls up to the 1.9 version. So now it's also available for any kind of object without losing the parametric information. Okay. More new features. We have added the option to calculate intersections between roofs. So there are more options to combine roof types with that were unavailable up to now. We have also added the option to calculate beam joints at ends or calculate the cuts of beams at ends. Okay, so we can define a vertical or horizontal cut of beams. We have improved everything related to the import and export features of IFC files. And something very important, we now support external references that contains VisualARQ objects. Okay, so they show properly in plan views and section views, which is something that didn't work properly up to now. As a reminder, well, VisualARQ 2.0 will be free to upgrade for existing users. That means that if you buy VisualARQ today, you have the upgrade to the 2.0 version for free. The price will rise, okay? And there will be also commercial and educational licenses as they are now, so, and with the same policy as Rhino educational licenses. So they can be used for professional purposes and academic files can be interchanged with commercial versions, okay? Soon we will provide evaluation version of the 2.0. Right now it's only available for VisualARQ existing users, but as I said, in a few weeks will be available for everybody. Okay, so let's take a look at the new features live with an example model. Okay, so taking a look at the toolbar, we can see that in the VisualARQ objects, we have added these two new objects, the furniture and the elements. They work in a very similar way. Under the documentation toolbar, we have added the annotation object and these two new icons for the edit levels, for the level manager and for the section manager. Okay, now we will see how they work. And finally, the tools toolbar, we have added these commands to do Boolean operations between VisualARQ objects and Rhino solids. Okay, the option to add solids, subtract solids, and extract solids. And also we have added this toolbar for selecting VisualARQ object. It's kind of useful as well. So we can select all the walls at once, okay, or all the beams or any VisualARQ object that exists in the model. So we can quickly select all doors or any other object through these selection commands. Okay, so let's now take a look at the level manager and the section manager. So basically when we run the level manager, this level opens and we have added here two new options. Well, that is the existing option to activate the cut plane. So that means that for any floor we can activate the cut plane. So the clipping planes cuts through the model at a specific distance defined by this value. Okay, but also when we are in another viewport, for example, if we work from this top viewport and we rotate the model, let's show everything back again, we can change the viewport to the top. Well, we can align the view to a level, to a specific level, and put it in the top view. For example, if I want to show the level 1, I can just select this and select this icon to align the view to that specific level. And also this command enables the cut plane of that existing level, and also keeps the display mode that I'm using. For example, if I'm using, for example, the shaded mode, I can now select the terrace, align it, and then model will show the terrace floor with the same display mode. And this icon here does something similar, but on one hand it makes a zoom extents of the floor selected. For example, I select the floor 0 and click on this icon. It makes a zoom extents and also changes the display mode of the current viewport to the hidden display mode. Okay, and I will explain why it does that. So in a similar way, the level manager works. Now you can manage sections from the section manager. So this basically, let me show everything back again. This dialog basically shows a list of the existing section lines that we can see from here, and we had created using this section command. You can now create new sections from this icon as well. So we can, for example, create a section. It can be a jogged section as well. Okay, define the direction. Let's call this section D. And now from this section manager, we can activate the dynamic section of any of the section lines. For example, we can select the section C and activate the dynamic section. Okay, or can select the section B just by double clicking on the specific section the model shows in section view. Okay, and of course it will update according to the position of this section line. Right, when I uncheck this, the model turns back in the full view. And you can already guess what these icons do. So if I am in any viewport, I can select any of the section lines and align the view to one specific section. Okay, I can do this for any of the sections I have in the model. Great, and in the same way, I can activate this icon to just extend the viewport to the section line position and putting the viewport in hidden display mode. This is important because when we're going to print, for example, a elevation or a plan view, let's move to this page layout where I already created a couple of details. If I click inside this detail, I can select, for example, the level 1 or the ground floor, while in this other level I can show the terrace floor. And since these two details are in hidden display mode, I can already print this in vector output. Okay, so basically I select the printer, I can select the vector output and just print this directly to as a vector output. So let's choose a name for this file. These are plans. Let's name this as a floor plans. And we can do something similar with another page layout where I've set here some detail views. So I'm going to choose, for example, section B, align it to the viewport, while in this case I will choose the section C. Okay, and now I can print this also directly to PDF using the vector output. So let's call these sections. And furthermore, if you want to have like a 3D view also in vector output. This is basically a 3D view of the model. I made sure I'm using the hidden display mode, okay, which is the condition to be able to print this in vector output. And now I can just, again, print this page layout, choose the vector output, and finally give a name to that PDF file. This is 3D view. Okay, so let's quickly take a look at these files, how they look like. As you can see, this is the 3D view generated. So we get a closer look. We can see that this is actually vector output. Okay, 2D lines. If we do the same for the other plans, we can also take a look at these drawings, and we can see that all the hatches and the lines have been created. Okay. Finally, let's take a look at the floor plan. Great. So no need anymore to use the make2d command in most of the cases. Okay, let's go back to the model. And now we will see one of the most important new features of this version, which is the option to create objects from Grasshopper definitions. Okay, as you may know, when we edit any VisualARQ object, for example, a door, we know that there are some limitations because the existing parameters only allows you to create certain types of combinations of designs. Okay, to cope with this problem, there was the option to assign a block, a 3D block, for the 3D representation of an object, in this case the door, and also a 2D block for the 2D representation of the door. But what if we could create this door using a Grasshopper definition that lets us create it with totally freedom? So basically, this is what we have done in the new version. So I will open Grasshopper to show you an example of a garage door. Okay, we can see here the preview of what Grasshopper generates. And on one hand, if we take a look at the definition, we see that here we have some parameters that define like the door width, okay, or the door height, and some other parameters for the thickness of the leaves or the aperture of that door. This is a door that you couldn't do it with the existing parameters of door styles. Okay, so the only way to do this would be using the option to create a block and assign it to a door style. Okay, so we have on one hand a list of input parameters. On the other hand, I have two geometry params, two geometry components that are required to for VisualARQ to understand that will be the components of the new style that we will generate. So basically, I've used this geometry param. I've renamed it as leaves in this case and as frame in that other case. And now I just save this definition and I will open the door styles back to create a new style, but in this case I will choose the Grasshopper style. So I just need to select the Grasshopper file I've just saved, click next. Here I can choose the style name, I can choose the units of the definition because it doesn't necessarily have to be the same as the document units. Here I have the option to select like a curve that is used to calculate the cut, the opening profile. In this case, I select the auto option because just the bounding box of this geometry fits with the shape that I want to perform as the shape to cut through the wall when I insert the door. Okay, so the auto option just calculates the bounding box of the geometry and generates the opening according to it. But if you have like a different shape, you can add like a new param in the definition to perform as the as the curve for the opening. Now, if I click next, I can see here the two components that I had in the two params in the definition. I can decide whether I want to import both or all of them or not. And now in this step, I can see the list of all the parameters, all the inputs I had in definition. And each one, I can decide whether it's available, is editable by style, by definition, or by object. Okay. If I set the parameters editable by definition, means that they will be hidden in the VisualARQ dialogs. Such is the case of all these integers that were useful in the definition, but I don't need to see at all in the VisualARQ dialogs. Okay. In case of the aperture, this is a parameter that I want to edit individually by each door item in the model. And since this is a percentage, I can change the type into percentage. Okay, so it shows this value as a percentage. There are other values that I want to edit also by object, such as the height or the width of the door. Okay, and the others are available only for style. I click next. Here there is an option to assign these parameters to each one of the components. Okay. And when I click finish, the garage door is just another door in the list of door styles in my document. So anyone that now opened this file will just be able to insert a new door. Just notice that the new insert dialogs now are docked in the side of the interface. If you prefer, they can be floating dialogues as well, but now it's easier to dock them here in one side to be able to work easily. So now I can choose the new garage door I have created and insert here in the model as any other garage door, as any other door. If I select it, I can see all the parameters that I left editable by object here integrated in the list of parameters. For example, I can change the aperture to any other value, or I can change the width to any other value for having a parametric door. Okay, or I can choose any other door in my document and also change the style for this garage door I have just created. All right. Great. As you can imagine, this functionality, this integration will let us create an unlimited number of new objects, and all the users can create their own library for new parametric objects. Good. And this is related to, you can do the same with the new object we have added in this version, which are the furniture element and the element object. Okay. If we take a look at how these objects work, we can see that here there is just one existing style, and a regular furniture or element style just uses a block for the 3D representation and also can use a block for the 2D, for the plan view. Okay. So for example, we can create a new style. In this case, I choose a furniture style that will call a block for a chair. So here there is a list of the models of the blocks that I'm using in the document, but I can import one from this icon. And here just look for the Savannah block library where there are some nice blocks. In this case, I choose a chair. And now I have a new style for that, for a chair. Okay. Now I can insert this chair. There are some insert options. For example, I can choose the alignment of the chair, and just, for example, insert the chair here in this balcony. Okay. The interesting part of it is that as the same way as we created a door from Grasshopper, we can create also a new style using a Grasshopper style. Okay, so in this case, I will choose a definition that generates a table. A very simple definition, but at least I can have like a parametric table for this object. So this is a parametric definition that creates two components, like a table board and the legs. And here I have all the parameters that define the shape of this table. So the depth, height, and width will be parameters that I want to edit for each table item in the model, while the other objects can be a parameter by a style. For example, the leg width is something that I can leave by a style, okay? And yeah, that's it. So I click finish, and now I can have like let's, for example, insert this table in this dining room. I choose now the table, and later on I can select it and change all the values that were editable by object. Okay. All right. Now let's take a look at finally at the element. So the process is the same. So there are already some styles available. They are using blocks that I previously introduced in the document. But in some cases, as I said, it's useful to have also a block for the 2D representation of this object. For example, in case of the tree, I'm using a 2D block for showing this tree, in this case, in 2D. If I uncheck this option, I mean, if the object doesn't have a specific block assigned for the plan visualization, it just takes like the projection or the real cut of the project, of the model. Okay, and when I see this from the top viewport, we see the 2D representation. But while if we rotate it, we just see, well, the 2D representation disappears, and we just see in this case, the model in the real section. So let's put this back to top viewport, okay, and move on. Also, the elements have one difference between the furniture element, between the furniture object, is that they can get any IFC category. So while all the VisualARQ objects, for example, a wall, so it's exported as an IFC wall, okay, or can be selected to be not exported, elements can be exported as any IFC category, as you can see in this list. In the same way that when we create any Rhino element also can be exported using this IFC tag as any IFC category. Okay. Good. Let's move on. And let's take a look at the annotation object. This is a new object as well, similar to furniture and element, but in this case it's aimed at 2D documentation. Okay, so this basically works in the same way. So you assign like a block for the 2D representation. We can create a block, for example, for this scale symbol. So we can just select this for creating a block for this scale symbol. And now we can just define this style as the scale symbol and select this to the symbol, well, this block that we have just created. But also we can create annotations from Grasshopper definitions, and this gets interesting because we can get advantage of all the parametric functionality that we can have within a Grasshopper definition. For example, I would like to show you one case of a definition that basically generates an elevation mark. Okay, this is just a definition that on one hand generates a text, and on the other generates this circle with the cross for the reference, for the elevation symbol. This text is required. It comes from this component here, and is required by VisualARQ to understand it as a text, also integrated in the object. Okay. So here we have some parameters. For example, 1 point of reference, and we can choose the number of decimals, or some other values for this elevation mark. So we save this, we close, and now we can open back the annotation styles, and we will create a new style using this elevation mark definition. Okay, so let's look for the file, click next. Now in this case we need to select the point that was in the definition as the insert point, and this is required because all the information of the text will be referenced from that point. Okay, I click next. There is also the option to assign a hatch pattern to the definition. This option is not yet developed at 100%, so the hatch still doesn't show up. So we will hide this by now, but it will in next versions. I click next, and now there are some values that can define by object, like the text size, okay, or the number of decimals. And finally, I've got a new annotation object that basically recognizes the height, the elevation, where is it inserted, and shows the elevation value. Okay. Or if I move to that level, I can place the elevation here. All right, so I have like a parametric annotation object that is totally customizable since it was created from Grasshopper. Okay, let's move on. Another important feature we have added in this version is the option to add new parameters to not only VisualARQ objects, but also to Rhino geometry. So as you know, when you select any object, for example, a wall, and we take a look at its parameters, we know that there is a style, there is a volume, an area, length, okay? But what if we wanted to have a new parameter, for example, the fire rating, okay, or the thermal resistance? So right now, if we click here under this icon, there is the option to add new parameters by object, but they can only be created by style and by document. Okay, so basically here we write the name of the parameter, for example, fire rating, choose a category that are basically the categories listed here, like general or another one that I can type here, and finally the data type. Okay, good. Now when I select this wall again, I have here the new parameter added in the list of parameters. I can just edit this parameter or remove it from here. And I can do the same from the styles dialog. So if I go to the styles, to the wall styles, I can select one style and here also add a new parameter for this wall style. Okay, again selecting one category, and just here you can add any value. And finally you can do the same but by document, okay, because all these parameters that I've been showing how to add in individual objects or individual styles only affect to that specific style. But what if we want to create a new parameter that affects to the entire model? In this case, you have this option integrated in the Rhino document parameters. Here in this icon, there is a shortcut to the Rhino tools options. And here under the document properties, there are the document parameters. So we can add one now that it's the price, for example. Okay, let's choose one category, and we can add another that it's, for example, the fire rating again. Okay. Good. And now we can tag any element, not only VisualARQ objects, but also Rhino geometry with this information. For example, I can say that this railing will cost, I don't know, 100 euros. Okay. Or the fire rating of this wall, it's like 30 minutes. Okay. Or if I have also a geometry created with Rhino, under this icon here, I can also assign information according to these document parameters that we have created. And of course, we will be able to list all this information later on in tables. Okay. All these parameters can also be created from Grasshopper. So let me show you an easy example how to do this. So we'll open here a definition that, well, just create some slabs, some beams on that light well. So here, basically, there is a definition that references a surface and generates the the beams, the structure for this surface. Okay, so basically this is a surface that I have plotted. I have extracted the two edges of this exploded surface that basically and divided into different points. Okay, I've joined these points with lines. Okay, so if I change the number of divisions, you can see the different divisions, the different lines. And finally, I have created, using these lines, I have created some beams that you know that the beam component located here under the VisualARQ tab, you know that you can create all the VisualARQ objects directly in Grasshopper. And in this case, the beams just need a path curve, and on the other hand, needs some additional options. For example, the style they are using or the profile. Okay. In this case, I have referenced an existing beam style. You know that you can either create a new beam style also directly from Grasshopper or reference one style existing in the model. You have here the parameters to reference object styles. Okay. And here basically I need to, what I've done is set one beam style and select one style from the list. Okay. Also here, using this the construct beam style component, I can get the list of sizes that this style has. Okay, so basically we can see here this list of sizes, and just by selecting one of them, I can choose. Let me select this back again. I can choose which one of these sizes I am using. Okay. Let me pick another style, for example this one, and well, again, here I get a list of sizes, so just pick the one that I need. And here maybe we don't need so many beams, like 4 would be okay. Finally, once I've got the beams, now I'm using this VisualARQ set property to add information to beams. Okay, so here under the VisualARQ tab, there are some commands to, in this case, set a property. Okay, this is basically what I've done, what I've used it here. And in this case, I've connected all the beams to that component. The property I want to assign information with is the name in this case. So basically, I've used this property name that shows a list of the existing properties in the document. Okay, and well, just by using the concatenate component, I'm combining this text, which is the beam number, with a list of numbers that go from 1 to 4 in this case, just to fill. Let me just get rid of this component, just to fill the the beams with the name, with the text for the name field. Okay, and I've repeated the process, but in this case using a new parameter. So basically here I have put this component that is used for generating new document parameters, new document or new object parameters, because under this scope we have the option to decide whether the parameter is by document or by object. Okay. In this case, I will generate a new parameter, which is the weight of the objects, of the beams in this case. So this is the name of the parameter. This is the category where it goes. Okay. And finally, here just using the steel density value, I can calculate the weight of these beams just by obtaining the volume of these objects, okay, and just multiplying it with the density. So here I get the list of the weights of the beams and connected them to this set property component in the same way that we have assigned the name for the beams. So finally, when I bake this component, as a result, I get a beam that has the name fulfilled with the corresponding number, and here the total weight of this object. Now let's list this information in tables. So I'm gonna open the table styles dialog. I will create a new style, in this case for beams. Here I select the object type it refers to. Just notice that we can also list extrusion, meshes, blocks, curves, points, any kind of geometry in the model. Okay, so any object you have in the model with information can be listed later on in VisualARQ tables. In this case though, we just need the beam object. And here we add all the parameters we want. First we add the name. So here select the property it refers to. We add a new property field, for example, the style. And here we can add also the length. And finally, we can add the weight that we have just created. We don't see this, this parameter here in this list because right now the new params are not included in the wizard, but we will be able to assign it later on. So I click finish, and now if I take a look at all the different property fields, here under the parameters you can see the parameter it refers to. Okay, so in case of beams of any style, this parameter takes the parameter name. Okay, same for the style or for the length. But in case of the weight, that we couldn't assign it in the wizard, we need to add it manually here, and here under the parameter, I can identify this parameter that we had created in Grasshopper that has been integrated in the document in the moment that we baked the beams. I click OK, and now I can insert the table for the beams, for these few beams in the model. Okay, and here they are. All right, so this is pretty much the most important features that the new version has. There are others, of course. Maybe I can, just to finish, show some of the features with the space object. Okay, so let me just hide this. And basically, we have added two new commands in the space object that lets you choose any element in the model to be used for calculating the space area. For example, if we create a space in this room, let's do it from the top viewport. Okay, let's call it dining room. And of course, this table, this space is using one specific style that we can, just shows the name, but we can show also the area and any of this information. Okay. And we can take any object, for example, this chimney, for calculating the the area of the space. So here under the space command, we select the element set, and now this element is also taken into account for the area calculation of the space. As you can see here, the space already takes into account this object that was actually a solid. Okay, or you can unset an element for not taking it into account for calculation, for the space calculation. Also, as you can see, the spaces representation now are in 3D, so you can have an idea of the head of the space. Okay, and of course you can change this head from here as any other VisualARQ object. Okay, maybe now I can leave some time for some questions. So if you have any questions, you please use the right hand icon in the GoToWebinar panel, and maybe I can give you access to ask any question for everybody. So anyone that has a question that want to share with everybody, please use the raise hand icon. Well, I just invite you to download the new version if you are a VisualARQ users from the website. Okay. As I said at the beginning, we will release VisualARQ 2.0 for everybody in a few weeks. Okay, and just feel free to write me write to visualarq@asuni.com for any suggestion, question you have. Just wait, I see there is Charles that has a question, so I will just leave him access.
Hello, Francesco. It's Eva and Jacques here.
Hello, how are you?
We are fine. We would like to ask you a question. In fact, when you was showing us that there is a possibility to assign a 2D block to the 3D object, we have a question. Is it possible to assign different blocks? For example, when we want to print a window with more or less details. Do you understand my question?
I understand. This is not possible now. I mean, you can only assign one block for the 2D or the 3D representation of an object, but right now there is not the possibility to assign different blocks according to a different level of detail. Okay.
Okay. And have you ever thought about this kind of possibility?
Yes.
In the future?
Actually, this is a feature in the wish list. Okay, that many people ask about it. So we will do it in the future. For sure.
Okay. Because the layers of 2D blocks, they don't appear in the layers of the whole model, do they? The layers of the 2D block, for example, I don't know if you import some layers.
They should appear. They should.
Okay, so maybe this can be a solution to prepare a 2D block directly with different precision, with different details.
Yes.
And just activating the layers, we can, I don't know.
Yes, this is a possibility. We have to think about that and find the best solution.
Okay, thank you.
Thank you. So just for ending the session, I would like to thank you for attending the webinar. There is just one more thing that I would like to mention, that I just mentioned it at the beginning, which is that this model that I've been showing all the time had this block, which is basically a reference block from that contains VisualARQ objects from another model. Okay, so basically, if I delete it, I can insert it again. Okay, using this, well, the Rhino insert option, and it's important that you choose, when you do this, the embed and link, and this model basically contains VisualARQ geometry. Okay, so if I edit the original block, for example, I delete these windows, okay, and save this, I can update this this block using the block manager. And this is something that it looks pretty obvious, but it's a new feature of the new version, because right up to now it wasn't possible to see the VisualARQ objects in referenced blocks from other files. Okay, and now this option is included in the new version. So thank you very much, everybody, and hope to hear from you. Bye bye.